Okay, we're gonna get started. Should be a very short lecture today. Um, Today we're gonna cover uh, material that are, I would say, supplemental, uh, um, or I'll say that's good to know as a developer about relational database. I did mention that materials today on uh, is good for you guys to be aware of, not necessarily going to be covered on the exam, but I will take attendance today. Okay, so all right, so appending to what we already know about normalizations, right? Database normalization. So far we learned about first normal form, second normal form. Now, those as a review, the reason that we do it so that we are avoiding database redundancy and then just bad design as well, right? And uh, as a result of trying to avoid redundancy and bad design and denormalization, we are also helping us to avoid anomalies. So inconsistency and anomaly because of those redundancies in database designs, right? So remember we talk about the update as well as delete constraints, right? Actual normalizations does get to impact those efficiencies. Okay, so understanding normalizations are not just because okay, we want to have a design that, avoiding inconsistency and redundancy, but it also help avoiding anomalies. Okay. Now, remember also as a review, functional dependency, right? Functional dependency means A, therefore B. A on the left side, and then there's an arrow, and then B, right? So A in here, also known as the X, therefore Y. X here, or A, is the determinant. Y is the dependent, right? So that's if because of X, therefore Y. So X, therefore Y tells us that Y has the functional dependency on X. Okay, so for example, valid functional dependency here is our, for example, your keys. Therefore, any sets, because your keys, you get the sets of non-key attributes such as in this table, name, department, buildings, right? And then let's see what else. Department number, also therefore department names. Okay. This is a also a review of what we learned before on the keys, all type of keys that we talked about before, including super keys, where it's if you think of a set, superset means that it's anything in addition to the original set. Therefore, super key means that it's key plus the non-key attributes. And then the characteristic of normalizations, the higher level of normalizations uh, always covers the previous normalization form, right? So three always have two already, and two already has one already. Now, we are going to introduce what third normal form is today. Okay, so third normal form, in a nutshell, uh, similar to second normal form, where you want to eliminate partial dependency. Now, third normal form, you want to eliminate transitive dependency. Now, transitive dependency means that there are dependencies that exist without any key involved, meaning that there are non-key attributes that potentially being a determinant for another non-key attributes. That's what we call transitive dependencies. Okay, so for example, if you look here, so here is a scoring table. Okay, so there's marks, meaning how well the student performed. The total mark is the total highest grade that you can get for the exam, right? So the exam name here, doesn't really, it's not in here, at least in this table, is not a key. But the total mark here does depend on exam name, right? It uh it may also depend on, let's say, score ID for sure, or subject ID as well as exam name. But exam name by itself is a non-attribute, a non-key attribute, and it can be a determinant for total marks. And this is what we are called a transitive dependency, because exam name here is not part of the primary keys, it's not part of the combo keys either. Now, that's three. Third normal form. The third, a 3.5 normal form is also known as Boycott normal form. We're not going to go deeper to talk about fourth normal form, so we're going to talk about 3 and 3.5. Now, 3.5 is slightly more popular because it's uniquely 3.5 rather than just a even number, but also because it has a name called Boycott normal form. What third 3.5 normal form is telling us that if there is a non-trivial functional dependency, then it's a violation of third 3.5 normal form. Now, what is non-trivial dependency? Non-trivial dependency means that you have a non-key attributes that is actually can be seen as a determinant to a key attributes, right? So it's an opposite way a valid functional dependency, and that became a violations for 3.5 normalization 4. Okay, so for example, take a look at here the college enrollment table here. So student and subject, and there's professor. Now, professor here for this enrollment, you know, it's not part of the primary keys. It's not part of the candidate keys. However, the professor here in cases can determine the subject, right? And so let's say me, for example, I only teach database or data science. So there is a trace that you can get back to the subject that I teach. So in this case, it is an example of violations of 3.5, also known as the boycott normal form, that has a non-trivial dependency. So it's opposite directions where it's supposed to be a key that become the key a key attribute being determinant for non-key, but in this case is opposite way. Here's another example for you to review if interested. Now before these two that we go over today, 3 and 3.5 are, I would say, as I mentioned previously many times, I think as a good start of a software developer that evolved with designing a database, or you're starting off building your own app and that needs a database, and if it's relational, I think oftentimes I think two is good enough, two normal second normal form. Now, I did mention that 3 and 3.5 maybe slightly, in my opinion, slightly overkill. Therefore, I'm not teaching any further after 3.5. Now, you may ask me, okay, so then how do I fix my database so that 3 and 3.5 are also covered, right? So I can get my database all the way to 3.5 uh, normalization form. I think the answer isn't quite simple. That it's not like there's a shortcut like the first or the second normal form where I mentioned second normal form has a lot to do with creating a new table and then make it a transit table, and then there's some like eliminate many to many relationship, that kind of methodology. 3 and 3.5 or anything above that really is first thing you do is to identify the entity, which means your table or your schema, whether or not the data or the attributes are isolated to its sole purpose, meaning that, for example, an enrollment, like a college enrollment table here, the professor and the subject itself and the student ID, these three um, is enrollment, but the subject and professor should probably be isolated into a separate table. And so while you're number one trying to modularize your original table to become slightly smaller, that is the first step, right? Number two, the second step would be to create, to do the best practice. Best practice here is to, instead of reusing an existing attributes or a candidate key as the primary key, create or declare a brand new auto increment or auto created primary keys like blah 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 ID or SID, student ID, subject ID, or professor ID, or whatnot. Make a table of brand new primary keys. Normally, those two steps are your best bet to make your table clean to as close as 3.5, right? And if you're interested on the actual step-by-step on trying to fix your normalization, your database to 3 or 3.5, you're happy to, you can read the appendix um, at your own will and at your own time. But a lot of times after second normal form, the quickest methodology to fix your database to have it conform to 3 and 3.5 is by number one, looking at your table and then see if the data is isolated, relevant to the table itself, the attributes. And number two is normally creating a unique primary key, like creating a new column and a brand new primary key and make it into a primary key, right? And that column should be just a randomized or auto-incremented ID. Okay? Okay, so now that we cover supplemental normalizations, what we also need to cover is for us to know that connecting your database with your Python, whether it's Node.js or or like Express.js, whichever your stack may be that's connecting to the database, just like a printer that you just bought, you want it to connect it to work with your laptop. There is certain drivers or connection string, we like to say for database, that you should consider using. Okay, for Python is the ODBC, right? So if you have already started building your Python Flask or whatnot to your MySQL database, you probably are not stranger to the ODBC. So ODBC is the library of the connections, okay? And then so basically, as you can see here, pretty self-explanatory. You specify the server name, the type of server, the server name, database names that you want to connect it to. Remember, you have to connect it to the database, not the table. You need to specify the database you want to connect it to, and with your username and password. Okay. And then you connect it by declaring or constructing the cursor. Okay. And then with the cursor, you will be able to execute a statement or store procedures, as we learned last time we met. Okay, and so in this case, it's like a store procedure being executed by cursor. Now, this is one way when you do the execution. It does get executed on the server. Now, if you want your Python code, in this case, seen as a client, to retrieve the actual data, you need to have another uh, call method as fetch all, right? And then you need to assign all your result onto another variable. In this case, is the rows. Now, after that, you obviously there's a lot of methodology or methods. You just have to check on the library what you can do with the data, and maybe you want to parse it into arrays or array list or why not, or a table for your liking. It's not covering here, but you get the gist. Finally, this connection needs to be closed. Okay, I mean, obviously, if you don't close, you just risk memory leak. But this is similar to a singleton methodology, right? The singleton framework. So it's best for you to close it so that you don't get, I guess, if you don't close it, maybe somewhere else that you're calling it, you may get like a dirty data or like outdated data that you're not aware of. Now, similar to Java, instead of ODBC, Java, we could call it JDBC, okay? And then it's still just the library for connection to our DBMS, right? Everything else is very much similar if you're familiar with Java, right? And as you can see, uh, you would after executing um, the statement, you will need to use get result set in this case, rather than the fetch all in Python. However, you still want to make sure that you neatly close your connections at the end, just like Python. Okay, let's take a quick attendance, please. Now, because I remember I was very sick for our supposed lecture last time. So after this class, and after today's class, I will stay here for a couple more minutes. Uh, I need to run back to my office because I forgot the keys. But I will stay behind a little bit and to answer if you have any questions about the exam. Okay. Okay. Now, I know that most of you guys have already explored, if not already have worked on Docker containerizations before. And then so just let me just kind of highly give an overview. It's not a requirement for understanding Docker for a database class, but I would just quickly introduce and why and say why I would recommend if you do have time to try getting the Docker set up for your project and get the extra credits that you will get because the Docker. Now, as I mentioned before, right? If you never experience connections to database, aka if you never build an app or a web application that is dynamic, meaning the data changes based on your data sets, your backend data container, then you probably wouldn't necessarily uh, ex have been exposed to Docker. Now, the benefit of Docker's, I'm not going to go read through the DAC, but I would say that there's twofold. Number one is that it does eliminate a lot of issues with different type of operating system, meaning that maybe you have PC versus iOS uh, as a team, and having Docker give you sort of a standardized uh, orchestrated space for you guys to collaborate so that I guess there's no gaps between your developer colleagues and your teammates. So, and then a lot of time, there are applications that are um, that are with either different versions or pay or non-paid, free or not free, um, and based on um, your licensing or whatever you get with your class. But having to use Docker, a lot of time those would have a version that you could spun off on your container. A lot of time, almost every software there are for free, right? So that's the first reason. And the second reason, as far as collaborating, you are now introduced to database. And whether or not you've learned software design already, having to learn database means that your software development skills is it's now more than just processing and calculating, but now you have storaging, updating, uh, and dynamic uh, synchronizing uh, to your application. But that comes with a quick issue, meaning that when you're developing web or just application based software without any database involved, MongoDB or whatnot, you could check in or commit all your work into GitHub or CSV, whichever repo that your team choose. Um, but when you're involving data, um, then especially database, because it's not a flat file, uh, you don't want to consistently start off from scratch with local version of databases installed on your computer, right? You would either want to, if you don't use Docker, you would want to probably have a share hosted database server that keep your testing data there. Otherwise, if you don't have a hosted space, you would want to use Docker to containerize that database server as an environment and then keeping the data that way, right? And so that's the second reason, and that's more relevant to database. Obviously, there's other benefits as well, right? Because I would say like I don't know the exact number, but so far, in this generations, obviously a lot of applications are now cloud-based and cloud first even, and they may not have a local hosted server anymore. So and knowing Docker would allow you to become more flexible um, when you are working with different teams because it's um, whether you're using AWS or Google or Azure, they all taken um, Docker, and then that means that spinning off an environment would be a lot quicker and a lot easier, and therefore it's preferred by a lot of different companies. And if you know Docker, then you could get your learning curve will be slightly smaller, and then you will get up to speed quicker. Okay, now kind of reviewing on everything that we talk about since the connection string to your software design here, let's just have a quick review and just visualize the tiers and then the sort of like a topology of database and your web applications, right? And so the most easiest illustration is this. You have your client device, which have browsers or installed applications that has connection to the internet, right? And either it's application or a web browser based, meaning using web browser, then it's a web application that would be essentially written in a JavaScript library. If it was application, it would be in Java, whatnot. And then with internet connections via HTTP protocol, you get to connect to the server. Now, the server is not database server yet. It can be a database server, but normally it can be a database server, meaning that it can be a server that has both database installed, the database server installed, also your web server installed. It can be, but most of the time, it's just first the recipient server from the internet is just a web server that has your application installed. And that's where your Python, JavaScript, Java, or Node.js or whatnot will be hosted on. And then that server will essentially be talking to in our class relational database, if that is your choice, that server will be connecting to the database via whichever library you choose. However, those libraries are, it will be connected through connection strings that we just went about earlier. So the technology, as you can see, the web browser tiers, their client program will be probably in JavaScript and HTML, right? And on your application or web server side will be PHP, Java, or Python. Database system will be your MySQL or any other relational database type. And then you could also, rather than having your statements or having your functions coded on the application side using Java or Python, you could also code it, as we learned last time, store procedures, right? That will store and host it on the database. Okay, so as far as the tier wide, the architecture for the three-layer design, we call it the presentation tier for your client program. Middle tier is where your web host or your application business logic is. It's the steps between the actual data and your front-end user. Finally, you have database system here. And the database system is a whole data management tier is a whole lot of story. It can be broken down into simply just database administrations or database design, but there are a lot more that spun up in this era. Their data can enable data science, more work on machine learning, data warehousing, all because of data that you empowered uh, for these type of skill sets. Okay. All right. I will let you guys read about um, advantage and disadvantage of these three tiers design of web technology with databases. But last topic is data governance. First introduction to data governance. Now, I don't want to bore you guys with a data government because you guys might think that, okay, some of you has interned before and you may interact with risk team or compliance team, and you think that that's the data governance are normally their job, which is not completely wrong. But I think that if you look at data governance, it, I think that it's a process in most place in the world, most company in the world, is the process of collaborations that is a collaboration between the risk team, the legal team, compliance team, and developers, or additional to like database administrators, right? Because fundamentally, there needs to be people that understand the database, the type of database, and some of the feature or capability of the database that came out of the box in order to implement such data governance, right? So the data governance is not only about what goes into the database, what goes out, but it also is about how long you need to store these database, who have access to this database, how do we purge the data, or how do we archive the data? If we were to delete it, how do we delete it? And then what are the policy and tool for us to make sure that there's certain backups and making sure that what uh, became not efficient, and we should be aware of usability of the database, or maybe even buy more hardware or scaling more, etc. Um, some of the disaster without data governance are obviously loss of data, number one, but more or less, more than losing the entire data, uh, without backup or any type of situations of data loss. It's not common today to entirely lost data because even if you are a relational database, it has automated backup. And on top of that, cloud also, uh, a lot of time these days, has this automation tool. If you use cloud to host your database, that normally has different images and replicas and distributed across different regions. But data breach does happens a lot more than losing the entire sets of data. And when I mention data breach, it's not necessary like store procedure, but having sensitive data to be exposed to non-authorized user. And that unauthorized user could also be someone internal, not necessarily has to be someone completely foreign to your company. You also don't want to have disasters such as reporting uh, incorrect informations that leads to a decisions that is not properly informed or calculated. You also don't want people to be building data or a brand new database with duplicate efforts. Last but not least, you want to have data governance because you want visibility and transparency so that it's easier to manage when it comes to legal and regulatory requirements or audits to avoid penalties, right? Now, there are a variety of different type of data governance. In a nutshell, the data governments are a lot of time a back and forth work in progress from a legal standpoint as well as technical standpoint. The legal standpoints a lot of time will include how long you want to store the data, who has access, how easily we can retrieve the data for auditing, and then how do we send reports to auditor or compliance people, all that as a backup. But the other part is how do we enable uh, legitimate data access? How do we make sure that data are being read and accessed based on authorizations? Okay. Role-based entitlements. Role-based entitlements is a feature to relational database. Now, not necessarily saying that NoSQL doesn't have this, but NoSQL has its own ways, and then every single brand is slightly different. Where relational database, similar to, as you can see, your operating system, you can sign in as different user, and or if you're a Windows server users for some company, they're like obviously they install Windows um, operating system and then uh, on your laptop, on your computers, but really essentially it's actually Windows servers. And when it comes to Windows Server, there's all these uh, user authorizations and user groups, right? And then different user group can do different thing on the computer itself, right? So similarly to relational database, right? There is first what we call the role-based entitlement. And the roles-based entitlement, you can imagine it as similar to user groups, right? And then you can define manager as a role, or you can define developers or admins, or you define a role as God or what who know, right? And then instead of entitle each user individually their access level to what object, you can provision access level to these groups, also known as the role, right? Entitle admin with every single right to course enrollment database, right? Or entitle manager to performance reviews columns or whatever, right? And then you add user into those row or add row to those user, vice versa. Okay. Now, for relational database, the access level are not just as simple as schema level, right? You can definitely assign database access. As we know, you use user password, whatever that, we earlier on learning a connection string. So definitely database is one. Table is pretty easy to see who have access to a certain table, who has not. You can use row entitlement or user entitlement method. But not only that, relational database allow you to define access level all the way to columns and rows. Now, we learned DML and DDL before, and so the final one that we are going to close out today to touch on is called the DCL, right? And the DCL is all about granting what we earlier mentioned, access levels and revoking access levels. So pretty much what we need to learn about it is that sure. For most of the database, if you are a SQL database, you can have it done with these access level through the through the user interface, similar to a file system management system, right? Like Windows Server or just similar to your PC. If you want to grant certain rights, you can use the user interface, but you can also use DCL, right? The data control language, uh, which is just another type of SQL to do the granting and revoking. There are in total 9 different privileges that you can use SQL and a DCL to either grant or revoke. Okay, so first of all, you could, what we learned earlier is you could give access to rows or user on different object. And when I mention object, it's the table, schema, rows, and columns. But these are relations, meaning the right to select, the rights to insert, delete, and update. These are also something you could definitely explicitly grant or revoke as detailed as possible using DCL. So this is just to show the statements. This is the insert into statement. Um, and in the bottom, there's a select statement. So this just to show that if you want, you could get your access level as defined as whether or not this person can have insert into on beer, which is a table, and then also uh, a select access on beer. Now, the keyword to grant and revoke are simply grant, right? And then you say on with relations, which is select, insert, or whatnot, or objects to row or the ID of the user. And this is the example. You're granting select and update relations or statements to sell on sell table, update on price actually. So it selects on the table sales, but update only on the sales table's price column to Sally, which is the user. This is an example of granting. And revoke will be just changing the grant to revoke. Okay, hold on. Sorry. Let me correct. So grant on to Sally, but the difference here is revoke on and from. Okay, sorry. So it's not just changing the grant, but also instead of to, you have to change to from. Now, these are something that I'm going to like go through really quickly because I wouldn't say that it's necessarily something that you guys would immediately need to do for the project. Probably not. You shouldn't have to overcomplicate your applications for the project. Um, and this is, in my opinion, somewhat good to know basis. But the final 2 things I do want to mention is that just like foreign keys and primary keys, there's also integrity involved um, to be aware of when you're doing granting and revoking, because there's also cascade and restrict. And so, what do I mean by that? So, there's certain by default when you're trying to revoke an access um, that by default will get restricted because there's some ripple effect. And what are those ripple effects? For example, my name is Ellen, and I'm granting Billy some access level. with grant options. When I mention grant option, that means that not only do I grant Billy the access to those object or relationship, but I'm also allowing Billy to have the right to grant other people. That's what the with grant options mean, right? So I'm granting Billy not only the access, but I'm giving Billy the grant option, right? And then when Billy go ahead and create something also as access level to Chris, because he has the grant options, right? He can pass down grant option again. Now, if if I revoked, Alan revoked the access level and grant options from Billy, this is where it became tricky because normally the database is going to alert you and do nothing here because what would happen if this does get executed is that Chris, because its access level was granted by Billy, if you revoked Billy's access level and the grant options, Chris's access and granting options are automatically going to be removed as well, revoked. So this is similar to foreign keys and primary keys constraints. There are certain by default things that database will do, and then in most cases, because of this integrity, it will do nothing, meaning no action will take place unless you specify that you wanted to cascade or you wanted to do something else, right? And so this is just something that you should be aware of, that using grant option has meanings fundamentally on integrity, just similar to primary keys and foreign keys constraints. Okay, that's the last bit about this lecture. And everything else, if you're interested, there are more about granting even normalizations that you are free to take a look at. And I mentioned today will be a very quick class, but I want to, okay, first of all, if you don't have any questions about today's lecture and you also don't have any questions regarding the exam in 2 weeks, then you are free to leave. But next week, Tuesday, we don't have class as I'm storing that for you to study. So we won't have class next Tuesday, but the Tuesday after that, it will be in person and it will be on lockdown browser. You need to bring your laptop, a pen, okay? And in 2 weeks, that's when our one and only exam is going to be. Now, with that said, if you don't have any questions, whether it's today lecture or the exam, you're free to go. If you have any
Thank
questions,
you, Professor. Have a good day.
you too. Thank you. Feel free to ask if you have any question now.
Professor, how many questions are on the exam?
Sorry?
How many questions are on the exam?
I haven't decided.
Oh, okay. And what would you say is like the most important topics we should study?
Um, did you look at the recording of the
N
exam review?
no, I'll be honest now.
Okay, so it's still on your syllabus, so I would suggest that you go over that. There's not, I wouldn't say there is any, it just it's covering everything from before today's class. And the only thing I can say is that they are uh, the the points are heavier on writing basic um, writing basic DDL functions and and diagram. And you should, if you have not, you should absolutely go on your syllabus or your Brightspace and watch the exam review or on Slack. And also, if you haven't studied the last lecture, which I was sick about, and that's also provided to you, I believe, Brightspace or on your syllabus, the recording you should totally have to watch because those, whatever it's before today, those are going to be on an exam.
All right, Professor. Thanks so much. Have a nice day.
Yeah. Okay. Have a good day, everybody.
And Professor, you told
Yeah.
us to bring a pen.
Yes.
Uh, is is it gonna on the are we doing the exam on the laptop or just on the paper?
Both.
Okay, thank you.
Yep.
Mhm.